Here we have the function f of x equal to 0.5 times x to the fifth plus 2. And we want to find the area between the graph and the x-axis from 0 to 2. And so first, let's fill it up with 5 rectangles. So here are the 5 rectangles. Now let's find the areas of each one, the area of each rectangle, and then if we add them up, it will be 13.0624. And that will give us an approximation for the area of the shaded region. The function is 0.5x to the fifth plus 2. And let's look at the first rectangle. The first rectangle, this is 0 and this is 0.4. Since we're going from 0 to 2 and we have 5 subintervals of 5 rectangles, and so 2 divided by 5 is 0.4. And so that's why the width of each rectangle is 0.4. And so this is 0, this is 0.4. And we will use the right endpoint method, meaning we will use the right endpoint values to calculate the height. So this is 0.4. When x is 0.4, y is 2.002512. And so this point right here, x 0.4, y 2.00512. And so the height of the first rectangle is 2.00512. And the area is 0.802048. And now let's go to the second rectangle. This is x sub 0, x sub 1, x sub 2. And so the width will be x sub 2 minus x sub 1 is still 0.4 because all widths are the same. And therefore this is 0.4 and this is 0.8. We will use the 0.8 to find the height since we're using the right endpoint method. If we were to use the left endpoint method, then we would have used the 0.4 to get the height of the second rectangle. But when x is 0.8, y is 2.16384. And so this point right here, x is 0.8, y is 2.16384. And so the height of the second rectangle is 2.16384. And then similarly for the other rectangles, that's how we get the height and the area. So this is rectangle number 4, and this is rectangle number 5. And if we add the areas together, the 5 areas of the 5 rectangles, then we'll get 13.0624. And so the area of the shaded region is approximately 13.0624. But notice that the rectangles we're using with the right endpoint method, the rectangles, they're outside of the shaded region. And so this number right here, 13.0624, will be higher than the actual area of the shaded region. And so now let's fill it up with more rectangles so we can get a better approximation of the area of the shaded region. This is 10 rectangles, and we get 11.06. And this is 20 rectangles, and we get 10.16. And then 30 rectangles. And then now let's fill it up with 1,000 rectangles and see what we get. For 1,000 rectangles, we get 9.3435, so that should be a good approximation for the area of the shaded region. And now let's go fill it up with an infinite number of rectangles so we can get the exact area of the shaded region. As mentioned earlier, the width of each rectangle will be b minus a divided by n. So in this case, b is 2, a is 0, and then n is the number of rectangles or the number of sub-intervals. And so in general, the width of each rectangle is 2 over n. So if n is 5, then the width of each rectangle would be 2 divided by 5. If n is 100, then the width of each rectangle will be 2 over 100. And then now let's express the x of i's in terms of delta x. X of 0 this is x of 0, which is 0. This is x of 1. X of 1 would be x of 0 plus 1 width, or 1 delta x. So it would be 1, 0 plus 1 delta x, which is 1 delta x. This is x of 2. It would be x of 0 plus 2 widths. So it would be 0 plus 2 delta x. X of 3, it would be x of 0 plus 3 widths. It would be 0 plus 3 delta x, and so on. And so in general, x of I be I times delta x. And again, we're using the right endpoint method. So now let's go figure out the height for the ith rectangle. The function is 0.5x to the 5th plus 2. And so f of x of I, in the place of x, we put x of I. But x of I is I times delta x. And this becomes delta x to the 5th, and then times I to the 5th. And delta x is 2 over n. Delta x is 2 over n. And so this becomes 2 to the 5th, which is 32. 32 times 0.5 is 16. And then we have n to the 5th, n to the 5th. And so this is the height of the ith rectangle. And so let's say we want the height of the 5th rectangle, and n is 5. Then here in the place of n, we put 5, and then in the place of I, we put 5. If we want the height of the 5th rectangle, and then evaluate it, and that will give us the height of the 5th rectangle, and so on. So far, we have delta x, which is the width of the of each rectangle, is 2 over n, where n is the number of rectangles. And then x of I is I times delta x. And then we just found this, the height of the ith rectangle is 16 over n to the 5th times I to the 5th plus 2. Now let's get the area of the ith rectangle. So area would be height times width. The height is this expression. The width, delta x, is 2 over n. And then multiply this out, we get 32 over n to the 6th times I to the 5th plus 4 over n. So this is the area of the ith rectangle. And now let's get the sum of areas of n number of rectangles. So we have summation of 1 to n. So this right here, this is the sum of areas of n number of rectangles. And then in the place of f of x of I delta x, we replace it with this. And then summation of sum is just sum of summations. 32 over n to the 6 is constant, so we just put it in front of the summation notation here. And then this is summation of the constant 4 over n, because the summation is with respect to I. In this expression, there's no I, so we can think of it as constant. And summation of a constant is just the constant times n. And so this expression right here be just 4 over n times n. This is summation of I to the 5th, so we need a formula for summation of I to the 5th, which is this right here. And so now the summation of I to the 5th, we'll replace it with this. So this becomes this expression right here, and as mentioned, this is 4 over n times n, because it's summation of a constant as far as I is concerned. And then multiply this out. 32 over n to the 6 times 1/6 n to the 6, it'd be just 32 over 6, because the n to the 6 here, they were canceled out. And then next we get 32 over 2n, and then 32 times 5 over 12n squared, and then minus 32 over 12n to the 4th, and then this is 4. So this is the sum of areas of n number of rectangles. But we want the exact area, so we need n to be infinity. So let's let n run to infinity. So this right here, this is the sum of areas of an infinite number of rectangles. So we're allowing n to run to infinity. So as n approaches infinity, we get 32 over 6. This becomes 32 over infinity, which is 0. This will be 0, and this will be 0. And then we get 4. And so the exact area of the shaded region is 32 over 6 plus 4, which is 9 1/3. So the exact answer is 9 1/3. And when we fill the shaded region with 1,000 rectangles, we got 9.34, which is very close to the exact answer of 9 1/3. And so the exact answer is 9 1/3 for the shaded, for the area of the shaded region.